Welcome to the Xterra podcast. The Xterra mission is to explore and discuss the business of space and its effect on the national and global economy, as well as life on Earth. How does what happens in space affect your life every day? That's what we're exploring on the Xterra website, as well as on this podcast. My guest today is John Fischer, CEO of Brandywine Photonics. And John, thank you very much for agreeing to appear on the program today.
You're welcome, Tom.
Tell me, first of all, what does Brandywine Photonics do?
Okay, well, we build weather satellites for measuring, near real-time weather as well as climate. So we're very excited to have several programs with Air Force Research Labs and NOAA on this very topic.
And how did you get involved in that?
Okay, that's a bit of a story. So I left Naval Research Labs in 1999. And when the dot-com bubble burst, my consulting business, I decided to make my first spectrometer in my spare bedroom. So that was for ocean color imaging. And that flew on the ISS from 2010 to 2015 on the Hyperspectral imaging for coastal observing mission. So it was quite an experience.
And what's a spectrometer?
Okay, so if you can imagine, we see light in three colors, red, green, and blue. And color cameras have a second green band. A spectrometer, imaging spectrometer specifically, will see that image in 32, 128, many different colors, and be able to tell information about what you're looking at from that spectral fingerprint.
So how do the small satellites that you build compare to the large birds like the GOES satellite that's used by NOAA?
Oh, well, that's it's very interesting. As you know, these GOES satellites and what's called the Joint Polar Satellite System, they're providing absolutely critical weather information, which really impact our daily lives. However, these are billion-dollar missions. The JPSS was a mission of 4 satellites, was $16 billion, and the planned GEO-XO mission is going to be around $12 to $20 billion, and it's going to be unaffordable, or at least put a difficult crunch on the number of satellites you can launch. Small satellites, as the ones that Brandywine Photonics is building, or more specifically the cameras and the spectrometers we're building for commercial satellites, their cost is in the $30 million range. And that allows us to launch many more satellites and many more observations of many different types. For example, JPSS 1 and 2, they'll have a revisit time of 6 hours. So you'll need to, if you're landing your F-16 on an aircraft carrier, you may wait 6 hours landing it based on data that's 6 hours old. Whereas small satellites, you can launch much more of them and get data latencies on the order of an hour or half hour. And frankly, if I was landing an aircraft in a tight crosswinds on an aircraft carrier, I would want my data to be as fresh as possible.
Well, and very few F-16s have a 6-hour loiter time to wait to land on an aircraft carrier.
So yeah, so they use a lot of in situ data, but with SpaceX reducing launch costs, companies like Blue Canyon and York, and new emerging companies providing very affordable spacecraft buses. The bus is essentially the framework, and the camera or the inner instrument is what measures the data. When they're providing these at a very affordable rates, it allows more frequent data as well as higher resolution and more resiliency. As you can imagine, there's a tight space race between US and China, and there's a great deal of concern of what would happen to US economic security were one of our weather satellites, these very exquisite high performance flagships, to be no longer functioning due to nefarious activities or even just a piece of space junk.
Space junk is something we can talk about in just a little bit because we've just recently done a pretty major story on the whole space junk situation. But I want to go back and just clarify. So we're talking basically about CubeSats with Brandywine Photonics.
Oh, CubeSats are one of my dirty words. There's
Sorry about that.
There's a big misconception. I've seen, NASA presentations extolling the virtues of CubeSats. And frankly, there's some uses in the RF realm, like GPS RO, radio occultation. There's some good uses there. And some deployable antennas for the microwave for single band to do the microwave sounding. Sounding is just measuring the vertical profile, wind and temperatures. It's a critical measurement. However, if you talk to any satellite manufacturer, small and large, thermal considerations are the key driver, absolutely the key driver. And aperture. The larger the aperture, the larger the light bucket to collect your photons, the more signal you need. So our focus is on ESPA class. ESPA class is at a standard launch interface, and that is in the 200 kilogram to 100 kilogram to 300 kilogram range. Okay. So these are serious satellites. It's not a university toy, and 5-year mission life. So really comparable.
You mentioned the term hyperspectral. What is that and why is it important?
Well, hyperspectral imaging is merely taking many bands, measuring many different colors, and as you can, and be able to tell the, looking at individual signatures. For example, and it's broken up into two main areas. One is in meteorology, weather, and there we make hyperspectral measurements with our CHISI instrument, a compact hyperspectral infrared sounding interferometer. Sorry for the long acronym, but CHISI makes measurements in the infrared. So from that, able to tell, the wind, temperature and moisture profiles, doing some fancy science, versus altitude, very important for anticipating weather. The other end of the hyperspectral, which we've flown for land and ocean, is in the visible and shortwave infrared. And you look at programs like surface biology and geology, which is a new NASA program, and that solicitation came out last month. That's looking at health of vegetation, harmful algal blooms, more surface measurements that are critical to agriculture and marine resources.
So is your work mostly government contracts, or do you also work in the private sector?
Well, almost all of our work is in government now. Air Force Research Labs, Naval Research Labs, NOAA, and NASA. So those are our primary customers now. But this year we've seen a big change. We've seen a lot of interest from weather analytics companies and data analytics companies. So it's been, as you've seen the recent special purpose acquisition corporations, the big jump there. There's a huge amount of inflow of investment into Earth observation, among other things. And we're seeing a lot of interest from that area to essentially take NASA technology and make it affordable for the average data analytics company.
So does that mean you're working in partnership with the technology transfer program in conjunction with NASA?
We haven't worked with tech transfer, just because the best tech transfer happened like I was tech transferred. You need to tech transfer the people, not just the technology. So much of the technology, for example, when we did hyperspectral oceanography, we licensed a patent from NASA JPL. But now there's a lot of open literature out there that we really take the ideas and use our own internal research and development to expand upon it and create new technology.
People say that climate is what you expect and weather is what you find. So with all the interest in climate change, does Brandywine Photonics help measure and understand climate change, or is your business more weather related?
Well, I would say it's both.
Okay.
You know, weather data observations are what you're measuring now. So it's both the effects of climate change on what you're measuring now. For example, frosts in the, freezes in Texas due to collapse of the polar vortex, which was had some contribution from, they believe, from changes in the atmospheric winds, and as well as the wildfires. So we're both measuring, the effects on the weather due to, long-term climate change, as well as making observations, which will improve climate models. For example, our infrared sounder technology for measuring weather. Well, a byproduct is measuring greenhouse gases. So it's the same technology, but it's used in different models, some for weather models, some in climate models, to provide that to serve both markets.
What do you do besides weather? Do you use this technology for other kinds of Earth observation, or are you strictly in the weather business?
Well, we do. Many people don't realize that the Department of Defense relies critically on weather observations, and sadly, that has, can I use the word bungled? The DMSP is falling out of the sky, being decommissioned in 2 to 3 years, and it's a big question mark, as reported on Space News, whether there will be a replacement. So we're involved in the DoD aspects for weather observations, and trying to get new technology into the warfighters' hands for better mission planning. Weather's a key critical part of that. Also, we have we're the same technology in our mirror designs and spectrometer designs are very useful for intelligence, surveillance, and reconnaissance, ISR. So we see our best way to describe Brandywine Photonics is a small version of Maxar or Ball Aerospace. Some companies start small, and we're one of those. So ISR, space situational awareness, and weather and climate are all really based upon a lot of the same optical technologies that we are developing.
As a small company, what kind of challenges have you faced in getting a foothold in the industry and getting people to pay attention to you?
I would say, like all small businesses, cash flow is a concern. Contracts ends, and what do you do if the next contract is delayed 2 months? It can take up to a year between doing for example, our NOAA contract, with a sounder sat. They loved our MetNet mission. Loved the technology, 42 satellites making equivalent measurements to the current observations at a fraction of the price. But it's going to be over a year between the end of a contract and when the next one starts. So contracting is one of our biggest hurdles. But agility is a big advantage. So I would say that's probably the biggest one we face.
Did you work in particular with any incubators or particular investors that helped you get the company, if you'll pardon this pun, off the ground?
Well, I tried to get a partner when I started, and he didn't want to do it. So, I have poor family. My father was a truck driver growing up, so I don't have any Harvard classmates, graduate of Penn State University. And so we're entirely bootstrapped. Me and my wife are the sole owners, and we're having our employees join us in some of the equity sharing. But so it's been, we're just outside of Philadelphia. So I think Brandywine Photonics is like Rocky in the 8th round, and Apollo Creed. So I've taken my lumps. Sequester was brutal. We hit the mat on that one. But now we're, getting stronger, climbing those the staircase up to the art museum.
We're talking with John Fischer. He's the CEO of Brandywine Photonics on the Xterra podcast. And John, let's talk about some of the information that you gather. Is your information gathering done in real time, or is it data that takes kind of a state of the world measurement for comparison to other data over time?
So that's a good question, Tom. Well, our first launch is in 2022 with a multispectral imager for one of our Air Force Research Labs customers. That will take it's an instrument called a theater weather imaging cloud characterization sensor. We went through a small business innovative research grant, so SBIR. That will initially will just take, it'll take a little while to get from shutter closed to process data, probably about an hour from downlink. But our objective for MetNet is, I'll call it weather at the speed of light. Why do you want to wait 6 hours for your data, or even an hour? You want that data right away. So there's a big advance by Space Development Agency for optical intersatellite links. And we hope to leverage that and other similar platforms to give our nation real-time weather data.
So do you see, as part of your customer base, companies like the Weather Channel and others that are providing online consumer grade weather information to folks?
I see that a lot of these organizations, they're very consumer facing, and we'll probably feed into I'll call the middle market. Companies like Atmospheric Environmental Research and other weather analytics companies. And it's really going to be transformed, the marketplace. What we see the future is what we call Met Market, which is an open data platform for weather and climate observations.
Who else is on your team?
Well, we have at Brandywine, we have seven technical experts and 3 co-ops. So a small team of 10 people. So it's very exciting. You have to be multi-talented. I'm a lens designer by training, so it's a big change from going to running a company and doing cybersecurity for part of my time. So that's and we have other companies as part of the MetNet Alliance. The MetNet Alliance, and welcome to anyone out there in the audience, is I'll call a loose confederation of small businesses and a few large ones whose passion is for measuring weather data. And we all have our own swim lanes. We have a partner for microwave, partner for weather analytics, one for GPSRO, radar occultation, and then detector suppliers, which is the secret sauce.
What, excuse me, what capabilities and facilities does Brandywine possess to help your customers achieve their goals?
Well, last year, a year and a half ago, we were just an office with a couple of desks. And this year, we built our own clean room. We moved into new facilities. We built our own clean room and built our own thermal vacuum chamber and our own lens assembly and telescope assembly. We did this. We could have bought it, but we're cheap, and like all bootstrapping. And also, infrared technology is a different beast. It really is difficult, and it requires a lot of specialty equipment to measure multiple instruments simultaneously in the vacuum of space, or simulated vacuum of space.
When you talk about that kind of technology, what, John, do you kind of foresee as the next technology that will come along that will help out in weather observation? You talk about infrared. I know there's microwave, and there are many, many ways that they can measure those things. But what do you see coming down the pike?
Okay, there's different aspects. I see I'll go from the aperture down through the data system. Apertures, we see things growing larger. Not CubeSats. Okay. We're going to fill up that fairing. If you can give me a $12 million launch, I'm going to make that aperture as big as possible. Okay. So we're looking at 50 centimeter to 1 meter apertures. So go big or go home is our approach, while still being affordable. So it's that price performance cost trades. The other is detectors. It's said that a satellite is just a detector with just a couple other things around it called optics and spacecraft bus. Mm-hmm. So we're developing new detectors with some of our partners for infrared sounding. The other is, of course, the spacecraft buses, which mainly thermal engineering. Cryogenics and thermal engineering are the key technologies, long life cryocoolers. And lastly, I can't leave a talk without mentioning AI, machine learning, and Internet of Things. That's a key technology which really, when you're doing, I'll call physics-based modeling, you have to have an exquisite spacecraft, and you want everything perfect, like GOES and GeoXL. But when you have 40 satellites, then machine learning and AI takes off. It's the best thing possible. You merge different data sources, whether stratospheric platforms, buoys, different modalities of limb and nadir observations, and you put all the data into the soup, and you get something that tastes great, and you don't know why.
We talked for a moment earlier about space junk and CubeSats and small satellites, and the amount of, I've seen estimates that range from 23,000 to 26,000 objects the size of a softball or larger in low Earth orbit at this time. How does that affect what it is that you're trying to do? I hear about, the terrestrial telescopes can't shoot through all the space junk that's up there. What's it like coming from the other direction?
It should be scary for the United States. Our weather architecture. We are one marble away from losing key weather observations. If something hits the JPSS, in a critical area, that's or goes, it's not going to be pretty. What happens to our observations of hurricanes? So that's why one of the key roles of our MetNet constellation is have a disaggregated architecture, where if one satellite should be lost, then there's another one that either is right behind it, literally, or can be launched within a few months. So resilience is one of the key aspects of the MetNet small weather satellite architecture.
You talked a little bit ago about launch costs as well, and we've all seen those launch costs continue to fall, with SpaceX obviously in the mix, companies like Rocket Lab that are doing some interesting things in launches and getting their spacecraft reusable. With those dramatic drops in launch costs and the cost of space technology dropping overall, are you looking at an increase in demand for the specific and specialized weather data as it applies to space launches?
Yeah, I would say it's more an enabler. If your launch was $60 million or $120 million, you're going to spend a lot of time and effort in making the most, a Class B mission, which is in NASA technology is, pretty much dotting your I's and crossing your T's, 1,000 times. Huge. You spend 10 times as much on mission assurance as you do on the satellite. Making sure there's absolutely no errors. But if your satellite can fail or the launch can fail, you just launch up another one. So now that enables launching lots of small satellites, and if it blows up on the pad, no big deal. You launch another one, and allows disaggregation, launching lots of satellites into lots of different orbits. For example, the AM orbit is really in dire need. We're going to lose 2 of the POES weather satellites, decommissioning after over 10 years, and lose DMSP. And the lower cost launch allows experimentation, trying something new, whereas traditionally NOAA wasn't allowed to try anything new because their operational mission, and failure was not an option. Where with the lower cost, failure should not just be an option, it should be a necessity for learning.
That's what Elon Musk says often, is that space is hard and he expects to blow some up before he actually gets it right.
Yeah, and it's but you know that mentality hasn't been accepted by the payload sponsors.
That makes sense. No one wants to see their payload blow up on top of an experimental rocket.
Yeah, but the problem has been that NASA is always for example, I heard a NASA official say that scientists will spend their whole lives on one mission, and that's just plain wrong. Buy 2 satellites. This is simple. I mean, it's so simple. Plan on building 2 satellites. The first one launches and it's imperfect and it's a tech demo. Great, you learn, and then you launch the next one. And it's going to be, 5% of the price as if you only built one.
John, we ask this of all of our guests, and I'll ask you as well to look out, if you will, over the next 10 years in space commerce and your role in that, and tell me what you see.
Well, I see a lot more NASA giving up more of the Earth observation responsibilities. Frankly, missions like SPG, they could be easily done by commercial. So a lot more of the Earth observations will be done at a fraction of the price. So what Elon Musk has done for launch, I believe there'll be a host of companies, not just one, but 10, 20, 30 Earth observation companies that will do the same that Elon Musk has done and SpaceX have done for launch. These companies will do the same for Earth observation. And Brandywine's Photonics role with our MetNet Alliance partners will be to provide our nation with to be able to measure the whole Earth everywhere, all the time, in near real time.
That sounds like a great place to close. John Fischer, CEO of Brandywine Photonics, thank you so much for taking some time to talk with us today.
Okay, well, thank you very much, Tom.
We've been talking with John Fischer, CEO of Brandywine Photonics. And that's going to do it for this edition of the Xterra podcast. Find us on the web at xterrajsc.com. And be sure to connect with us on LinkedIn and follow us on Twitter at XterraJSC. Until next time, I'm Tom Patton. Thanks for listening.